welcome everyone to this lecture on vectors. So, when we talk about physical quantities in this world, we have a lot of quantities like mass, temperature, force, displacement. So, all these quantities contain some information within them. The vectors are those physical quantities which have a magnitude and a direction, and also follow triangle rule of vector addition to complete the information within them. So this is called a vector quantity. So a quantity like force, for example, we have to open a door. So what we do is that we apply some force and we choose a direction to apply that force. Now whether we have to open or close that door, depending upon that, we direct the direction of the force. So in that particular case, how the force is applied in addition to how much force we are applying is important. So direction is an important quantity in that case. That's why we say that the force is a vector. That is, it is a physical quantity which has both magnitude and a direction. Now scalars are those physical quantities which only require a magnitude to describe them. For example, a man is walking down stairs, so he must have traveled some 50 meters or 100 meters. And to describe how much distance we have traveled, we do not have to associate any direction with it. So only magnitude is important in that case. So it's a scalar quantity. Other examples of scalar quantity are speed, temperature, density, uh, relative density, and all other quantities. On the other hand, vectors are those quantities which require direction with them also, like velocity of a particle or acceleration of particle, uh, the magnetic field in space, the electric field. So all these are vectors. So how do we represent a vector? So when we have to write a vector, we just select a letter, let's say A or D, either capital, either small, and we put an arrow on top of it. So this whole the letter and its arrow on top of it becomes a vector. So this is how we represent it. So all these quantities A vector, B vector, D vector, all these are vectors. Next, how we draw them? So first we select how much, what is the unit with which we want to draw it. So let's say we have selected the unit 1 unit, which is drawn here. So 1 unit is this much long. This we have already selected. Okay, this is 1 unit. And then we say that let's say we have to draw a vector A which is 3 units long. So when we say that a vector is 3 units long, we mean that that vector has a magnitude of 3 units. So by which we mean that how big that vector is. There is also a vector alongside A which is B vector whose magnitude is 2 units. That is 2 units long. So we can say that vector A is higher in magnitude than vector B. So to draw vector A, what we have done is that we have repeated 1 unit 3 times, 1, 2 and 3. So this whole becomes A vector. And since we know that the vector must also have a direction, we have put an arrow on top of it. So this arrow shows the direction of the vector, and how long that arrow shows the magnitude of the vector. This B vector, it is drawn like this. It is 2 unit in magnitude and its direction is shown like this. So this is B vector. Below it, it is written that the magnitude of A vector is 3 unit and magnitude of B vector is 2 unit. So how do we represent a vector? We put a capital letter and put an arrow on top of it. How do we geometrically draw a vector? we draw an arrow, and how long that arrow is shows that how big that vector is going to be. Okay, so we have introduced vectors. Next, the first vector which we are going to study is a zero vector. So zero vector is denoted by 0 and we put an arrow on top of it. This is called a zero vector. The zero vector is one which has no magnitude and its direction is indeterminate. That is, we cannot say in which direction that vector is. So that is called a zero vector. Next, what a vector is made of. That is components of a vector. The vector is made of two things which we already studied in its definition. So first, it is made of a magnitude, and second, it's made of some direction. So the magnitude of a vector is represented by the writing the vector, that is A and an arrow, and putting a mod sign, that is two parallel lines to the left and right of it. So this is called the magnitude of vector A. So this is one way of writing magnitude of vector, that we put a capital letter A, put an arrow on top of it, and put it within a mod sign. So this is magnitude. One more way is to simply write the letter itself. This is also an acceptable way of writing the magnitude of a vector. Next, what is direction of a vector? So we have to write the direction of vector A itself. So we put a cap on top of it. ठीक है, तो इसको हिंदी में कहते हैं टोपी. So this vector is A and we put an cap on top of it. So this becomes the direction of a vector. तो इस वेक्टर को हमने टोपी बना दी, तो ये वेक्टर का डायरेक्शन बन जाता है. Next, what is a unit vector? The unit vector is one which is whose magnitude is equal to unity. So unity means that the magnitude of vector is simply 1. So any vector whose magnitude is equal to 1 would become a unit vector. So what we draw is that we put a letter A and put a cap on top of it. Same cap which we put for the direction of a vector, we are putting for direction of for the unit vector. So this cap denotes that this is a unit vector. So this B cap, this is read as C cap. So all these are unit vectors, and since they are a unit vector, its magnitude, which is represented by putting a mod sign within it, is equal to 1. Next, there are some standard unit vectors which are called I cap, J cap, and K cap. So these are unit vectors which are predefined and they are along x, y, and z axis as shown here in the figure respectively. I cap is a unit vector along x axis, J cap is along y axis, and K cap is along z axis. So these are fixed unit vectors. A cap, B cap, C cap, these are some general unit vectors which can have any direction. The next, we have co-initial vectors. The co-initial vectors are those whose initial starting point is common. So this vector A and B start from the same point. So the starting point of a vector is often called the tail of a vector. So when the tails of two vectors are coinciding, we say that these two vectors are co-initial. So for example, force is active on a body, they are co-initial vectors. Co-terminal vectors. When the arrowhead of the two vectors coincide, then they are called co-terminal vectors. Their heads are coinciding. Next, we revisit the magnitude and direction of the vector. The vector is made of a magnitude, that is how long it is, and its direction, that is in which direction we want the vector to be. So the magnitude of vector is represented by the vector and putting a mod sign around it, and the direction is simply A cap. So we multiply the direction and the magnitude to get the vector. So we want to write the direction of vector. then we know that the magnitude is only a scalar quantity. That means it can be multiplied and divided. So what we do is that we bring this scalar value, that is a magnitude, and we divide the vector with it. A vector upon a magnitude becomes the direction of the vector, as shown in this equation. So this equation is important. So like we already knew, a cap is a unit vector which shows direction of a vector. Next, we want to multiply a vector by a scalar. So how do we multiply a vector by a scalar? Uh, for example, we have chosen to multiply a by 2. So this becomes 2a vector. So what we have done is that we have produced a one more time. That means we have produced 2a and combined both these vectors. So the new vector is going to be twice as long as the earlier vector. So this vector is a, and then we drew a again, and then adding both these vectors we get 2a vector. Similarly, uh, if we want to half this vector a, we want to half this vector a, half a, we have to draw. So we draw the vector a, we drew a, and then we halved its length. So this new vector is half of the original vector. So this is how we multiply any scalar quantity with some vector. Just its magnitude is changed and its direction is not changed. Now on the same idea, how do we change the direction of a vector? So we study the opposite of a vector. The opposite of a vector is simply changing the direction without changing its magnitude. So let's say we have drawn a vector A. So we have to reverse this vector. So simply the arrow in which the earlier vector was pointing is reversed and its magnitude is maintained. So this is the reverse of the earlier vector. This is minus a vector. So this is opposite. Next we learn to add two vectors. We have in previous 2-3 pages learned how to write a vector, what is a vector, and what the vector is made up of. Next we want to add these two vectors. So to add two vectors, first we would see that how to draw and add. So let's say that we have two vectors available, a and b. So these two vectors a and b, they are drawn. So first of all, we can shift these vectors parallel to themselves without changing the vector themselves. So even if a and b are not in this position, we can bring them in these positions by shifting them. So how do you shift them? So let's say a vector was somewhere here. So I have shifted a from this point, from this area to this area, and let's say b vector was somewhere here. So I have again shifted b without changing its magnitude or direction. So that means that shifting a vector parallel to itself does not change it. So next what we do is that we have to add it. So there is a very simple idea which is called triangle rule of vector addition, and if you remember, this was also included in its definition. Our definition said that a vector is some physical quantity which has a magnitude and direction and must follow triangle rule of vector addition. So when it follows this rule, only then it becomes a vector. So what is this rule itself? The rule says that if you have two vectors, just coincide the head of a vector with the tail of another vector. Any vector with any vector. So head of one vector with tail of another vector. The remaining head and tail are to be joined in the direction from head to tail. So we joined this tail, This was the remaining tail. This head was coinciding with this tail. This is the remaining tail. This is the remaining head. So we have joined the remaining tail and head in the direction from tail to head. So this is a very useful way to find addition of any two vectors which you want in any case. So this was the rule. So let's apply this rule in this question. We have to find A and B. We have to simply draw it. So here the vector A's tail and B's head are already coinciding. So the remaining tail is here and the remaining head is here. So join the remaining tail and head in the direction from tail to head. So this is A plus. Next, A and B, they are both opposite to each other, right? So now the tails heads are coinciding. These are co-terminal vectors. You cannot directly add them. So what we do is that we shift some vector. Let's say we want to shift the smaller vector, B vector. So we shifted B vector in such a way that the tail of B lies on top of head of A. So thus repeating that statement, the tail of B must lie on the head of A so that we can join the remaining tail and head as was written here. Remaining tail and head is to be joined in the direction from tail to head. So we have joined remaining tail with remaining head. So this is A plus, which we wanted. This was the remaining tail, this was the remaining head. These are joined. This is A plus. Next, we have to find magnitude of A, where A is given as some 2n I cap. So we know that I cap is the direction. The quantity which is beside the direction, or you can say the coefficient of direction, is called the magnitude of the vector. So here the direction is this. This is the direction. So this is the magnitude. This is the magnitude. So here we have drawn 1 Newton. We have doubled it, so it gets 2 Newton. So that's the magnitude. Next we have polygon law of vector addition. The polygon law of vector addition says that if you have multiple vectors, so just join the tail and head of the consecutive vectors. So if tail and head of consecutive vectors are joined, like we have joined here, A, B and C. These vectors are joined like this. So the last remaining tail and the last remaining head are joined in the direction from, we know it, from the direction of tail to head. Tail to head. So no matter how many vectors are there, 1, 2 or 3 or more than 3, we join all these vectors and the remaining tail to remaining head is 3, sum of the 3 vectors. Next, what we want to focus is on parallelogram law. The parallelogram law is the important one which would be used many times. So we have to focus here. So the law itself says that a parallelogram, we have to draw a parallelogram and it has two sides which are unique. The other two sides are equal to the opposite sides. That means that the two adjacent sides must be the vectors which we want to add. So like you are seeing in this figure, this vector is A, this is vector number 1, this vector is B, this is vector number 2. A and B can be added in this way. So if these two vectors are adjacent sides of a parallelogram, then the diagonal starts from the initial point of the vectors and ends at the opposite end is equal to the sum of the two vectors A and B. So this is A plus B. So this is parallelogram law. For example, a parallelogram is formed like this. So this is a parallelogram. Let's draw one vector here. A vector, B vector. Let's say C or D. Changing the name, this is C, this is D. So we learned that these two have to be the adjacent sides of a parallelogram, and to add these two vectors, we do is that we take the initial point and end the vector at the opposite end, opposite vertex. So this diagonal which starts from the initial point is simply the sum of the two vectors which we have chosen. This is C plus D. So parallelogram can be of any type. It can be a rectangle, it can be a rhombus, it can be a square. The diagonal which starts from the initial point would be the sum. Okay. So after adding the vectors in a geometrical way, that is rather than concerning that what is the actual magnitude of the vector and what angle it makes with the other vectors, we have just geometrically added them because we have learned how to draw them. So this is how vectors are visualized in the world. So this visualization is important to study that how much force is acting or how much displacement has happened or which particle has higher velocity. But we still want to know that what is the magnitude of the vector which we added, or as you will learn further, which we subtracted. So how do we do that? So to proceed in that direction, we study resultant of two vectors, and it is called analytical addition of two vectors. So what do we mean by analytical addition? The analytical addition, we say that now we know the magnitude of the vectors. That means we know how long the vector is, whether it is 2 centimeter long or 3 centimeter long, how long that vector is. So let's say this is the magnitude of vector number 1, A. Vector B, the magnitude is B. Angle between the vectors is theta. So these are the quantities which we would start any problem in vectors mostly and in further chapters. So what we do is that first we find the magnitude of the resultant. So the magnitude of resultant is represented by R, and its value which we are going to calculate is going to be square root of A square plus B square plus 2AB cos theta. So this formula is similar to A plus B ka whole square and with the cos theta in the 2AB term. So how do we arrive at this formula? There is a small derivation. What we do is that we write a vector A. So this vector is A. There is another vector B. So A vector and B vector have an angle theta in between them. And we know from parallelogram law that from the common point we start the sum of two vectors. The sum of the two vectors is A plus B, that is this diagonal. It is represented by R here. So that you might be wondering what is resultant. The resultant is actually the magnitude of the sum of the two vectors. So let me write what resultant is. Resultant is the sum of the two vectors. In simple language, A plus B, when they are added, we get a vector, and this resultant is the magnitude of that sum. So it sort of represents how the vectors are added. So this is the length of this vector sum is R. So this angle is theta. The resultant vector makes an angle alpha with A. that is the sum makes an angle alpha with it. The sum of the two vectors makes an angle beta with B. And what we know about this particular parallelogram, we know the side A, we know the side B, and we know the angle theta. Only three things we know. What we want to know more is what is the length of the diagonal alpha and beta. So this becomes a pure mathematical problem now. So we would treat it as such. What we would do is that the B, this side, the opposite side is this one. So this side is also B. This angle is theta, parallel sides, and this is a transversal. So this angle is theta. I hope that is clear. So this, we extend this particular line. So this is the important point. This particular side A is extended up till the point that K, the perpendicular from the opposite vertex, drops on this point in this way. So this figure, if you draw this figure on your own, you would easily be able to draw this. Just extend the longer side A and drop a perpendicular on top of it. Wherever the perpendicular lands, just stop drawing A from there. Extending A from there. So this is B. Now we have to find what are the sides of the triangle. So this side is B cos theta, B sin theta. This side is B. So we have drawn the triangle. So how is this B cos theta? So from trigonometry we know that the side which is closer to theta, or which is adjacent to theta, is called the cos theta wala side, and the side in front of theta is called sin theta side. So the side in front of theta is B sin theta, but that is how sin theta is defined. Sin theta is defined as the perpendicular, which is this side which we want to find, divided by hypotenuse, which is B. So if we take B sin to this side, the B sin theta is equal to the perpendicular. This is B sin theta, and let's say this is base. Base is named A or some S, let's say, for consideration. So the base upon hypotenuse. Base upon hypotenuse is cos theta. The base becomes B cos theta. So now, after studying this triangle, let's take a look at the bigger triangle. So this bigger triangle. Now, do you think this is also a right angle triangle? The answer would be yes. The triangle which we have drawn just now is also a right angle triangle. It is the same 90 degree as the previous one. So this side is R. This complete side is A plus the base of this triangle, is B cos theta. So this is A plus B cos theta. This is B sin theta. Again repeating, this is A plus B cos theta. This is B sin theta. This is the base of this triangle. This is the perpendicular of this triangle. We know that perpendicular square plus base square is hypotenuse ka square. This is the Pythagoras theorem. So the base is A plus B cos theta. This is for the bigger triangle. This is B sin theta. This is again for the bigger triangle also. So base ka square plus perpendicular square is equal to square of the hypotenuse. So the hypotenuse, which was the resultant, is square root of A plus B square plus B sin theta square. So when we expand A plus B cos theta, we get A square plus B square cos square theta plus 2AB cos theta plus B sin theta square. So this is B square sin square theta. Now we have to add B square cos square theta and B square sin square theta. So when we add these two quantities, cos square theta plus sin square theta is 1. It's a popular identity. So this whole quantity becomes simply B square into 1, which becomes B square. A square remains as is, 2ab cos theta, which came from the expansion of this bigger square, remains as is. So we have derived the formula for resultant of two vectors. This is called analytical addition of two vectors. So what this means from now on is that if you know any two vectors, A and B, and don't know their magnitude, so you can use this formula to find the magnitude of the resultant of the vector. That is a square plus b square plus 2ab cos theta, and put a square on top of it, square root. Then we have to find alpha. So alpha is determined indirectly. We say what is tan alpha. So tan alpha is perpendicular upon this base. So again repeating, tan alpha is this perpendicular upon this base. So this whole perpendicular is b sine theta. This base is a plus b cos theta. So perpendicular upon base is equal to tan alpha. Similarly, we can also write tan theta. So we simply exchange a and b. So in place of b, we have a. In place of a, we have b. In place of b, we have a. So a sin theta upon b plus a cos theta. This is tan alpha. So from these two ratios, we can find tan alpha and tan beta. We already know alpha plus beta is theta. So this is the next, we want to study some particular cases. That what happens if something special is given in the question, or something special is given in something which we want to study. Let's say if it is given that these two vectors have equal magnitude, A and B have the same magnitude. But their magnitudes are same, right? A and B have the same magnitude. So A and B would be equal. A is equal to B. So if we put A equal to B in this formula, so this formula becomes R is equal to 2a square plus b square, since A is equal to B, plus 2a into A, because B is also A, cos theta. So we take out 2a square. So when we take out 2a square, we get root 2a. And we get 1 plus cos theta. Now 1 plus cos theta is equal to 2 cos square theta. So this is a well-known identity which you should learn. Is 2 cos square theta by 2. This is called a half angle formula. 1 plus cos theta by 2 is equal to cos theta. Actually, this 2 comes over here. Okay. So we have 1 plus cos theta. 1 plus cos theta is replaced by this quantity, 2 cos square theta by 2. So when we calculate it, we get this. So this is an easier formula. When two vectors are equal, their magnitude is simply the sum of their magnitude is 2a cos theta by 2. And we know that alpha would be equal to beta. Since a and b are equal, all this ratio would be equal to this ratio. So one thing which we can also say that if alpha is equal to beta, then that would be simply equal to theta by 2, since alpha plus beta is theta. So from that comes a very important natural idea, that is you have two vectors which are equal in magnitude. This is a force, this force is applied on some body, and another force is applied on some body. Let's say I've drawn somewhere here. Assume that these two vectors are equal in magnitude. So by natural observation, we know that if two vectors are equal but they have some slightly different direction, and this force is trying to pull this particle is being pulled in some direction. So if you want to know that in which direction could it be pulled, so it would be somewhere in the middle, right? It won't favor this vector or this vector. It would be pulled somewhere in the middle. So this is what this fact is saying, that if alpha is equal to beta, then the resultant vector would be bisecting the angle between the two vectors. Okay, now we have to simply plug in some general quantities. Let's say, okay, what if it were the case that if theta is 90 degree. So if theta is 90 degree, then we put theta over here, the cos 45 degree. The cos 45 degree is 1 by root 2. So this becomes root 2. So this is a common problem again. Let's say this is vector A. Let's say this is vector B. The angle between these two vectors is 90 degree. And these two vectors are equal in magnitude. So then by Pythagoras theorem we know that the sum of these two vectors would be a vector like this. Let's say magnitude of this vector is 1, this is 1, so this would be root 2. So this quantity is also saying the same thing, that r should be root 2 equal to whatever the values these have. And this vector must make equal angles 45 degree with both the vectors. What if the angle between the two vectors is 0? So if two vectors are collinear and their magnitude are also same, then they simply add up. So this we saw already. So the sum of these two vectors would be 2A. And the angle which the new vector makes with the vectors it is made of is simply 0. So alpha and beta both are 0. If the two vectors are opposite to each other, then they would cancel out. For example, a book is being pulled by two students fighting over it. So the students are pulling the book in opposite direction. They are trying to pull the book in opposite direction. So the book would be torn apart. So this is how they are pulling the book. The book won't go anywhere. So both the forces are cancelling each other out. What if the two vectors are not equal to each other? A is not equal to B. So that this formula would be valid. Let's see how we apply it. So if theta is 0 degree, that is the angle between two vectors is 0, they would simply add up and the resultant would make 0 degree with them. If the two vectors have an angle 90 degree between them, then r would be equal to a square by b square, Pythagoras theorem. If the two vectors are opposite to each other, then the resultant would be the magnitude of bigger vector minus smaller vector. Now the mod sign is put here so that if a is less than b, then also it comes to be positive. Since r is the length, it has to be positive, so we put a mod sign. So even if this is negative, it comes out to be positive. Okay. So now some conditions are given here. If a is greater than b, alpha is 0 degree, beta is 180 degree, and if b is greater than a, then beta is 0 and alpha is 180. So this is left as an exercise to you, that how we arrive at these angles in these conditions. So this can be easily solved by using geometrically adding two vectors. That is using the triangle law of vector addition. If you use that law, then you would easily get why alpha and beta are these angles. Next, we want to proceed further to the questions. So first question is that find resultant of two vectors a and b. whose magnitudes are 2 and 3 respectively, and the angle between them is 60 degrees. So there are two vectors, the magnitude are given and the angle is given. Find the magnitude of resultant. All these questions must contain magnitude of the resultant because that is what we want to find. So R is equal to square root A square, that is 2 square, plus B square, 3 square, plus A into B, 2AB cos 60 degree, square root 4 plus 9. Cos 60 is half. So 2 is cancelled by 2, 2 into 3 is 6. This is root point. This is the sum of these two vectors. Magnitude of the resultant. Find the resultant of two vectors A and B whose magnitude are 3 and 4 and the angle between them is 90 degrees. So this is again a very common problem. 3 square plus 4 square plus 2 into 4 into 3 into cos 90, which is 0. So this is simply 5. Next question, the resultant of two vectors A and B whose magnitude are 5 and B is 5 root 2. The angle between them is 90. So we apply the formula R is equal to square root A square, that is 5 square, plus B square plus 2 into 5 into B into cos 90, which is 0. Now R is equal to 5 root 2 and this is equal to this whole thing, which is 5 square plus B square. So 5 root 2 is equal to 5 square plus B square. So squaring it, we would get 50. So 50 is equal to 25 plus B square. So B is 5. Plus minus 5. We would ignore the negative quantity and take B is equal to 5. Is it possible that resultant of two vectors is smaller in magnitude than the vectors it's composed of? That's absolutely possible. Let's say I draw a vector like this and a vector drawn like this, and let's say I want to add them, triangular vector addition, head is coincided with the tail. The remaining vector is like this. Even better, what I can do is that we can extend this. Let's say extend this. Yeah. Now these two vectors are pretty big. You can see, right? So this the sum of these two vectors is smaller than the vector it is made of. Two vectors of equal magnitudes are inclined to each other at an angle theta. The magnitude of the resultant is equal to A. Find theta. So we can use the formula which we have just learned. A is the resultant is equal to 2A cos theta upon 2. Cos theta upon 2 would be half. This means theta by 2 is 120 degree. Yeah, cos theta by 2 is half only. 60 degree, right? Yeah. If cos theta is half, then that particular angle is 60 degree. Theta by 2 is 60. Theta is equal to 120. So in this particular question, we have two vectors of magnitude 5 root 3 and an unknown magnitude b. They are inclined at an angle of 150 degrees. If the magnitude of resultant is 5, we have to find the magnitude of the other vector. So the resultant of both the vectors is 5. So 5 square is equal to 5 root 3 square plus b square plus 2 into 5 root 3 into b into cos 152 25 is equal to 5 root 3 square, that is 75 plus b square. Cos 150 is uh, minus root 3 upon 2, so this would become minus 50. So this becomes b square minus 50b plus 50 is equal to 0. So this gives two solutions for the value of b. One is 5 and the other is 10. Next, here we have three vectors of magnitude p each. Two of them are inclined at an angle 2 theta and the other two are inclined at an angle theta. We have to find the resultant of these three vectors. So what we would do is that we would add two vectors separately first. So these p and p would have to be added. So we already learned the formula for adding two equal vectors, that is 2a cos theta by 2. Here the magnitude of each vector is p and the angle between them is 2 theta. So 2 theta by 2 is theta. So that would be the vector 2p cos theta. Next we have to add this black vector with this one. So the angle between these two vectors, since this vector is bisecting these two, this angle is theta, then that angle again becomes 2 theta. So adding again we get 2p cos theta square plus p plus 2p square cos theta and cos 2 theta. So this would become some 4p square cos square theta plus p square plus 2p square cos theta cos 2 theta. So thank you for watching this lecture.